So this is a picture of reflection, but we are not really doing reflection now because we are doing refraction. So just now we were discussing about the idea of light ray passing through two medium. Okay, so you can have a situation like this. This is the medium, maybe, okay, a glass block. So the light passes through. From the normal line, you have an angle, incident angle, and then you have refracted angle R. Okay, so I'll call this medium 1, this one medium 2. So sine I over sine R is a constant. We have explained about this just now. So this constant is what we call a refractive index. This is called a refractive index. Refractive index, basically it measures the optical density. Okay, it is actually comparing the optical density of different medium, of a specific medium N. So just now we were having a semicircular block, and this semicircular block is one type of material. And if this one type of material has a certain value of sine I over sine R, which is constant, that constant is what we call a refractive index, this one. But we need to be careful because basically if I have this case of ray coming in from medium 1 to medium 2, so I should write something like this: 1 and 2 equals to sine I over sine R. Sine I over sine R. Okay, pay special attention to this point because most of the reference book they didn't mention it. So in this case, sine I over sine R is going from 1 to 2. But this notation or this formula of 1 and 2, it's actually the refractive index of the material 2. Okay, let's start a clean new page. We have this boundary. This is material 1 could be air, material 2 could be glass. So we have this. So we have I here, and then here we have R. So 1 and 2 is actually sine I over sine R, and 1 and 2 is actually N2. This is actually the optical density of material 2. Optical density of material 2. Okay, why do I say that? What if, okay, just now the arrow was, I use a blue arrow, the arrow was this, okay? What if now the arrow has changes? The arrow has changed here to here. Can I say this is a 2 and 1? So this one will equal to sine R over sine I. Okay, I want you to make a conclusion that 2 and 1 is actually the optical density of material 1. In this case, air. Okay, this one is air, and this one is probably glass. So the conclusion is start with a new page. 1 and 2 is actually N2, so it's actually sine A over sine B, which is, if I draw a very large diagram and I have this is A, here is B. Okay, this 1 to 2 is actually the refractive index of 2 sine A over sine B. And then what if you go from 2 to 1? 2 to 1 is actually the refractive index of 1. So that will be sine B over sine A. Okay, so this relationship is very important because sometimes it could go from 1 to 2 indicated by black arrow, and sometimes it could go from 2 to 1 indicated by very light fluorescent blue. Okay.